You can determine whether two sets of numerical data are related by graphing them as ordered pairs. If the two sets of data are related, you may be able to use a line to estimate or predict the values. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. Most scatter plots are in the first quadrant because usually the data is positive numbers. Now you can use scatter plots to find trends in the data. The scatter plots below show three types of relationships that two sets of data may have. As the x's increase, you may tend to see the y's increase. That is called a positive correlation. And your picture would look like that. A negative correlation is happening when, as x increases, the y's tend to decrease. And you have a scatter plot that looks like this. And then finally, if the y and the x are not related at all, then the data sets have no correlation. Taking a look at temperature and altitude. If I use the data as x's and y's and plot them on a scatter plot located there, after I plot all that data, you will notice that this gives a trend of a negative correlation. When plotting a scatter plot, make sure you label your axes appropriately. This is dollar spent, so we'll make that X. Gallons bought, we'll make that Y. So let's do a scale of by 2. So 2, make this 4, 6, 8, 10, and 12, and 1, 2, and 3. So these are my ordered pairs. So 10 I will place at 2.5. These are approximate. 11 I will place at 2.8. At 9 would be 2.3. At 10, 2.6, so slightly above that one. At 13 would be 3.3. Make that a little darker. At 5, 1.3. 5, 1.3. 8, that is 2.2, so about there, and 4 is 1.1. So that's my approximate graph, a very rough sketch, but you will notice that as the x's increased, the y's are increasing. This has a positive correlation. Let's go back to answering B. B says, consider the population of a city and the number of letters in the city's name. Would you expect a positive correlation between that, negative correlation, or no correlation between the two data sets? Well, quite frankly, the population of a city has no impact on the letters of the that are in the city's name, so this would have no correlation. Two data sets have a positive correlation or negative correlation, and you can use something called a trend line drawn here to see the correlation more clearly. A trend line is a line on a scatter plot drawn near the points so that it shows a correlation. Now keep in mind, the trend line does not, I'll write that down, does not have to go through 0, 0. Okay, a lot of students want to try and draw that through 0, 0. It doesn't have to be, because look at this trend line that's drawn, okay, for this one. Notice it does not go through 0, 0. So building a scatter plot based upon the information given here, we find that there is a positive correlation, and we've drawn a trend line to represent it more clearly. Again, notice it did not go through 0, 0. Now, in order to write the equation of that trend line, what you can do is find 2 points that are either on the line or fairly close to the line. In this case, we selected these two. And use that information to write the equation of the line. Finding the slope by using y2 minus y1 over x2 minus x1, which is 5.2. And then the book uses the point slope form, but we use the y is equal to mx plus b method, where you find the b by plugging in one of the x and y's and then solving for, and the m, and then solve for b. But after you do all of that, we found that the equation of the line would be y is equal to 5.2 x minus 3.7. So now I can use that equation to make a prediction on the weight of any type of panda, okay, however old the panda is, because x is age in months. So I'm going to give an estimate of a 7-month-old panda by just plugging in 7, and I can expect that panda to weigh about 32.7 pounds. Creating a scatter plot and drawing the trend line. Again, once we create the scatter plot, we can then draw the trend line of the data based upon that scan of the plotted data. We won't spend time doing that again here. Now the trend line, once it is drawn, can kind of give you a feel for whether or not the line of best fit, once the trend line is drawn, I should say, it gives you a good rough feeling about what the line of best fit should look like. But there is a way to calculate the line of best fit using a calculator. Using your calculator, there is a value called the correlation coefficient. It's R in your calculator. And that R can indicate a strong negative correlation, no correlation, or positive correlation. And it's between a -1 all the way up to 1. If it's a -1 or close to -1, then it would cluster around the line of best fit more closely, but it has a negative slope. If it gets a correlation coefficient that's close to 1, then it is a line of best fit that closely resembles the data, but has a positive slope. As it gets closer and closer to 0, either from the -1 or from the +1, headed in that direction, as it gets closer and closer to 0, it becomes no correlation at all. So if you got a correlation coefficient of a -0.97, that is considered to be strong. A strong negative correlation, but a strong correlation. R of 0.34, that's closer to the 0, so this will be a weak positive correlation. A 0.82 would be a strong positive correlation. And a -1.2 would probably be a very weak negative correlation. In other words, I wouldn't use the line or the trend lines equation to do any predictions on this one because it's weak. I mean, it may give you some good data, a good approximation of what you can expect. Like on the panda bear situation, if I had a weak correlation with that, I wouldn't use it because if I plugged in that 7 like I did on the slide before, it may not give a good prediction for exactly what the weight would be. So these are what they look like. A strong positive correlation. Here's the scatter plot. There's the trend line. Notice that the data is kind of hovering around the trend line. That's a strong positive correlation. A strong negative correlation is drawn here. There's your trend line. Notice that the data values of the data ordered pairs closely resemble or closely hovering around that trend line. A weak positive, here's the trend line here, but if you notice, the dots are all over the place, so it's not a very good predictor of what the outcome would be. And a negative trend line here, but it's a weak negative because most of the ordered pairs are not closely resembling the data. So again, not a good predictor of what the outcome would be. Finally, we're going to talk about causation. Causation is when a change in one quantity causes the change in a second. For example, the number of loaves of bread baked and the amount of flour used. See, I would expect there's correlation for this because, the number of loaves of bread you bake directly correlates with the amount of flour that you would be using. And this would also have causation because the number of loaves you bake will cause the amount of flour to be used. The number of mailboxes and the number of firefighters in the city, I would expect correlation with that because the number of mailboxes, as it increases, I would expect the number of firefighters to increase in the city to cover those number of houses. But there is no causation. because the number of mailboxes does not cause the city to hire more firefighters. I mean, it has no impact on the number of firefighters in the city. The cost of a family's vacation and the size of their house. I would expect correlation, but no causation. Your vacation doesn't cause you to have a certain size of a house. The time spent exercising, and the number of calories burned. I expect correlation with that, and I would expect causation as well, because the hours you spent will cause you to burn calories. Number 6, the amount of time you study for a test and the score you receive. Yeah, you better believe it. There is correlation with that and causation. Some of you don't believe that, but there is causation. A person's height and the number of letters in the person's name. I don't expect any correlation with that, nor do I expect causation. Your homework, make sure you get your homework done, and we'll do the next lesson.